My programming journey, as I said, started when I was in third grade. So when I was 8 years old. So I've been doing a lot of, programming. I was involved in setting up a lot of communities. I was one of the early members of Math Stack Exchange, Stack Overflow. I contributed to numerous projects across Python, Python, even beyond. I was involved in writing.
Hey guys, welcome back to Entrance and Beyond. Thank you for waiting for one of the biggest episodes thus far. So today I'll first try to do justice to what my guest has done. Hopefully I'll introduce him well enough. So today I have Shivam Patel with me. He's basically from Gujarat, India. He did his early education down in India. But after that, some of the things that he has done, I'll try to mention all of them. So he basically did his MTech for Carnegie Mellon University down in the US. Apart from that, he has a lot of open source contributions. So he's contributed to projects such as Golly, PowderToy, and Blender, Fan, FANN, and Scikit-learn, and many more Python libraries. So that is his open source contribution. And now let's come to the main part. So the main part is he's done a lot of research internships actually. So he was invited as a researcher at MIT in the US. He's done research at Caltech. He's even gone to Quebec, University of Cambridge. You name the college, and he's pretty much covered all of the big colleges, and he has done a lot of good research down there. Currently, he's in Apple, so he recently switched to Apple. He's working on Siri, LLMs, RAGs, things like that. He's a senior ML engineer down at Apple, and prior to that, he was in Google. And one of the best facts, or one of his biggest achievements, I would say, is at the age of 12, he published his first research paper. He has an Erdos number of 2, and he's really good at math. So he's pretty much like a mathematician. Yeah, you can say he's a research person. He's an ML engineer. I think Shivam has pretty much done it all. So thank you so much, Shivam, for coming to my podcast. Hopefully, I did justice and I didn't miss anything out in this entire introduction. Hopefully, we'll get to know a bit more about you through this podcast.
Wonderful. Yeah, let's get started.
Yeah. So Shivam, before we go into all of this technical data, I wanted to know how your life was as a youngster. Because if you're someone that published a research paper at 12, I think from a young age you must have really got into mathematics or got a lot of knowledge that typically people at that young age don't really have. So I'd love to know a bit about your early journey, how things were back home, and then how you fell in love with math and how things were before, like you went to college and all.
Definitely. So I think there are two aspects of it, right? When you publish young, you need to know really a lot about the subject and what you want are doing research on. That is one piece. But there is another piece that you should know. You should know what publication is and that publication exists. So we can cover both those pieces. So I think for me, I was my parents. Both my parents are basically doctors. Both of them have like university affiliations, university professors, and both of them have published a lot of research papers. In fact, my grandparents have published research papers. They're also in the medical domain. So from a very young age, I knew what conferences were. I knew where what research was. So that piece where you would want to at least know what research is and what publication is and how important something like that is was clear to me. With math, I was really a very inquisitive child. More than that, I just really wanted to know. I really wanted to learn. And I was super fortunate that when I was in my formative years, internet was just starting to pick up, right? So I was introduced to the internet at like I would say age 6 or so. And at roughly age 8 9, I started programming just like most people do. You type things in Google, you get tutorials, and you start programming. I also got into math because I actually wanted to do astronomy. I wanted to study physics. And I was like, okay, if I want to understand physics, there's a lot of math I need to do. So that's how I got into math. I mostly taught myself math through a combination of a lot of books that were available online and a lot of tutorials. I mean, early internet tutorials were not that many, but there was like enough tutorials like Khan Academy and a lot of other resources where you could at least understand math until a college level. And that I was interested. I got to be interested in number theory, and I was able to procure books from around where I was from and from the internet. And I felt that there were ideas in which I could contribute to active research, and that is where I was able to publish at basically at that age. And I was also fortunate that I was supported by the local math community. I grew up in Ahmedabad, and Ahmedabad is Gujarat University, some of the best. math in the state pretty much happens there. So I was supported by folks, professors at Gujarat University. I was recognized. IIT Gandhinagar was being set up as a new IIT. So I collaborated with professors N.R. Ladawala and like IIT folks at IIT Gandhinagar. And so I basically got a really nice atmosphere of mathematical collaborations. However, I didn't write a paper with any of them, but it was more about like figuring out what questions are worth talking about, and having a community, and then that is how I was able to
Okay.
publish.
Okay, that's pretty cool. I guess the Gen Z folks might not relate to this because now we have ChatGPT, so you're not even ending up using Google nowadays. If you
Yeah,
want to learn anything, you just pull up ChatGPT. There's abundance of resources, but you really have to study. And that was quite interesting because I think when the time you're growing up, even Khan Academy and all of that, they're pretty new then. I don't think they
they were
were like
starting out. Yeah,
they were
they were
probably
starting.
starting out in those years. But like Shiva mentioned, that he had a good sort of backing from his parents as well, and I think that is important because probably in your household, people used to probably talk a bit about research and all that. Because yeah, at 12 years age, I don't think half the people even know what doing research exactly means, what publishing a paper means, because they're pretty much busy with, I don't know, playing or doing something like that. Nowadays, I don't know, maybe mm, playing games on your phone or something like that. But yeah, so that was pretty cool. So I wanted to talk about like then how did you like how was your college life then? Because I think during your college you did a lot of these researches, right? In various
Yeah.
colleges abroad. So how did you stumble upon those opportunities? Did you like cold email some folks, or did you get an invitation or things like that? Because I'm really curious about what you did in college, because a lot of people watching my podcast, they are in college nowadays, and they're quite I don't know, they're quite worried about what we should do in college. They want to use up their 4 years to the best possible way, and I think you probably did a pretty good job in that, given the fact that you've done so much in during your BTech. So yeah, I was curious a bit about that. How was your BTech journey? How did you end up landing these school opportunities abroad?
So, I mean, for me, my programming journey, as I said, started when I was in third grade. So when I was 8 years old. So I've been doing a lot of, programming. I was involved in setting up a lot of communities. I was one of the early members of Math Stack Exchange, Stack Overflow. I contributed to numerous projects across Python, Python, even beyond. Like, I was involved in writing a dialect of Python, and like overall, like, a lot of things. It was written my databases because when you're young, you have no goal. Like, you basically are not there to make
Yeah,
money. You're just there to have fun. And that is where, like, I think open source shined. Whatever I could get my hands on without paying a single dollar was what I wanted to do. And that is where I got into open source. I made a lot of friends, a lot of connections along the way. And I, of course, kept on publishing in computer science. I was kept on publishing in math, then in computer science. In fact, I wanted to do theoretical computer science when I went to college. However, if you do college in India, there is not a lot of, I think there's only IIT Kanpur and a few other places where there is some serious theoretical computer science, right? So it was very hard to be an engineering student in India and do theoretical CS.
yeah,
And back in the day, like, of course, machine learning, I was more interested in the statistical learning theory aspect of it, but that was gaining traction. And before actually I joined college, so when I was in 10th grade, I was involved in a project that basically Google open source TensorFlow, and I was involved
yeah.
in making TensorFlow. It's like the early version of TensorFlow. So
Hmm.
there was basically Cafe, Theano, and those kinds of projects, and I was essentially involved in contributing to those projects and making them better, compile, making them faster. And so that is where I got into deep learning, and that is where I made my first connection with folks, and I was invited to MIT to essentially do my first internship because of that collaboration which I had made there. It was once again in statistical learning theory and more on theoretical computer science side of things. After that, once again, I had many opportunities to do an internship, but I was really focused that I want to do something in an applied setting. So I didn't want to do theoretical. I think by second year, I was pretty determined that if there is any important progress you can make with these things, is not just increase the accuracy of something from 99 to 99.1%. It is actually do something at a practical level. And I had opportunities through my mathematical basically programming skills to actually contribute in biology before, in economics before, in a lot of other with a lot of other domains, and I used to love to do that. And that is where I basically emailed a lot of professors back in the day. It was not cold emailing per se. but it was very targeted. I knew what kind of work I had done before. I could send work samples, and I basically targeted would be like some. I applied to like some 400-ish, talk to some 400-ish professors. Actually, pretty low by today's standard. I don't think so. You get
Yeah.
anywhere if you just cold email like 400 people. But as I said, it was not just purely cold emailing, and a few of them definitely replied. And Caltech turned out to be so I worked with Professor David Van Wallen. That turned
Yeah.
out to be a perfect intersection between doing deep learning. So he was building deep cell v2. So there was a proper like looking into machine learning. Back in the day, state of the art semantic and instant segmentation algorithms were not as strong. So I was basically like, how do you take those algorithms? How do you take methods in traditional image processing, convert them into deep learning native methods, and get gains, right? So that was the
Yeah.
goal of that internship, and I was very fortunate to have gotten that, because it was, as I said, combination application, deep learning, and a new opportunity, and that is how I ended up coming to Caltech. And Caltech had this very nice program called SERP. It still have it. It's called Summer Undergraduate Research Programs, and WORP, which is visiting undergrad research programs. These are like quite prestigious, very hard to get into. But if you get into these programs, Caltech does pay a substantial amount of stipend. Substantial meaning good for for your like room and board, and also like it will be enough money for you to cover your flights, and it will give you subsidy really good experience here. Many years later, I now have my own surf students at Caltech who I mentor. So that is another very full circle sort of a moment. I am a visiting researcher in the math department at Caltech. Uh, so that is how it was. Yeah, so that is how I got these internships.
Okay, they're pretty cool. And then you also went to Canada, I guess, Quebec, right? Not Quebec, but
Yeah,
you went
yeah,
to Canada for
yeah.
the.
So
Um,
that was Mila, right? So essentially, after doing Caltech, I was basically also interested in, okay, what other things can I do? And
yeah,
I think coming from a mathematical background, I think back in and 20 this 2018, 2019, attention is all you need was published in
yeah.
2018, and there was a lot of interest in transformers and that side of things, and that is why I was like, let this field mature. Let's see what happens with that kind of a direction. So I was interested in NLP, but I was also more interested in RL, because RL was a combination of math and kind of the things I really liked. Control theory. I used to love building simulations. That is one of the things I've contributed throughout my childhood, and even in my adult life. I like work on Mesa and a lot of other simulation-based projects. And so RL was math plus simulation plus deep learning. So I kind of liked it. I applied to many places in my third year as well. A lot of programs like I think ETH Zurich, EPFL, and a lot of those programs. Out of all the CERN also I applied. So out of all the opportunities, the most aligned opportunity once again came up at Mila, where it was deep RL applied to policy. So policy once again was very applied, something really important, right? Not something very theoretical. So like climate policy, and RL was another like aspect which I wanted to explore, and so that is where I did multi-agent RL
Okay,
for climate
okay.
policy.
Okay. And I think something important that Shiva mentioned is that even like at that time he had reached out to around 400 plus professors, and like he mentioned today, with so much access to emails, LinkedIn, and whatnot, you should really reach out to way more people than that, and that is gonna help you in the long run. Like should have skills, but I think as Shiva mentioned, his connection probably helped him a lot once he had the skills, because he got to meet new people, get to do research with a lot of great mathematicians, great programmers, and got to really learn from these cool universities. And now he's actually mentoring there. So, now let's talk a bit about how you got into Google, how you got into now the tech world, because the work before this it was pretty much. I would say research oriented, correct? You're doing college,
Yeah.
you're doing programming, you're doing DSA, you're doing a lot more things. So how did you really enter the tech world, and what's going on currently in your life? Because you recently made a switch from Google to Apple, and those are pretty much the dream company of a lot of folks are getting into at least one of them. And now that you have uh, gotten into both Google and Apple, so I'm really curious about that. How you entered the tech world, and yeah, how's life been so far after you've entered the tech world?
So I of course did do machine learning when I was in my grad school. I did software engineering, I did machine learning, I did these kinds of things. And natural progression, of course, was one, do a PhD, and second, basically go to industry. And I was really confused. But one thing that was very clear is that the rate at which deep learning was progressing was exponential rate, right? And then there are these
Correct.
always these cycles, right? These cycles where there is an aha moments, like there's the CNNs invented, and then people put a lot more compute, and then they get saturated, and then there's basically GANs, and then people put a lot more compute, and things progress very fast, and they get saturated, and then transformers and so on and so forth. So
Yeah.
there are always these cycles, right, in deep learning. And the acceleration was a lot, right? And when those accelerations came up, I realized that 5 year for a PhD is actually too much time. Like you don't know, and especially if you're in that time where your PhD is where there is a new breakthrough that has already happened, and all you need to do is throw compute. Usually, academia does not have that much compute to throw, right? So then you would basically be catching up to industry in those changes. So the right time to get into academia and do PhD is when after throwing compute, you basically saturated the gains, and then now there is new methods that need to be found, right? And as of 2019ish, now I think new methods are also only found in the industry with a lot of compute, right? So that is why I decided to go to industry. And I got into a lot of companies. I got into basically Adobe, I got into Nvidia, I got into Meta, for a lot of companies. Once again, Google, because of how the atmosphere of deep learning was there at Google, and things were setting up. I decided to join Google, right? And there were like many products I could touch, a lot of applications I could do, and that is why I decided to go join Google.
Okay, that's pretty cool. Um, what are the skills that you feel that people need to enter the tech world? Because from your background, I think it's pretty clear that you first of all had a great fundamentals in mathematics. A lot of people might ignore that as well. So it would be great if you could shed light on that as well. How important are the fundamentals? Because I was recently doing another podcast with someone from IIT Bombay, and that is something that he was mentioning as well. Like when we enter college, we're quite confused by a lot of mathematics. We're like, why are we learning linear algebra? What's the use of calculus? Why are we doing all this mathematics when we just have to program at the end of the day? So, how important do you think the fundamentals are, especially in today's age where people, I don't think they're really interested in mathematics and things like that, because we're at an age where you can program quite easily, right? You don't have to be really technical. You can at least do some basic level of programming without having a lot of technical exposure. So how important do you still feel the fundamentals are, given the sort of era or AI age that we are entering in?
Actually, the question is more about, can you, if your question is more about can you program without knowing a lot of math, I think the answer to this question is yes, you can program without no, you can learn how to program without
Yeah.
knowing a lot of math, right? That is for sure, right?
Yeah.
You if you want to instruct a computer to do something, you can do a lot of it through essentially without knowing a lot of math. You need to know basics of programming. You should have basic logic, and you're good, right?
Yeah.
However, when the question occurs that can you do things like complicated machine learning,
Yeah.
constraint optimization, those kinds of domains, I 100% believe you require a lot of mathematical fundamentals to do that, right? The reason why is that, let's say you want to do anything in machine learning, and you basically look up any algorithm, like your gradients are updated through gradient descent, and you basically get some results. Now, let's say you're training something and you have instability in training, and the problem you're trying to solve is some niche problem, right, which is in your own industry, in your own domain, and you see that the learning is not stable. The model is somebody else built the model. The way you train the model, somebody else developed that model. You have the library. You can essentially you can use ChatGPT to generate the code to basically train your on your own data on that model. That is all doable, that is all easy. But when you run into a problem, you need a certain amount of mathematical intuition to essentially get out of that problem, to even understand that there is a problem and to actually solve that, and to have those. And irrespective of how smart the models become, or irrespective of how smart AI becomes, those kinds of things where you basically are the one who's driving the steering wheel, who's basically getting to build these models, who deriving actual value from these models, a lot of these mathematical intuitions are very useful, and those mathematical intuitions are built on a lot of facts that you would learn from the at a very fundamental level, right? So it's not about knowing methods that, I mean, I know how to integrate something,
Yeah.
or I know how to differentiate something. It is, do you have an intuitive understanding of what happens when things are integrated, right? I think that becomes more and more important in the AI age.
Okay. Okay. So yeah. Like in current days, what I notice is there's a lot, like things are growing exponentially. Like you also mentioned when you were thinking about whether you wanted to go for a PhD or you wanted to work in the tech world. That was the sort of discussions that you had. So a lot of folks that are in college or who want to maybe work in AI or ML or something like this, they don't stick to a single concept. Like they keep on like jumping things. Like if I'll try to explain, like maybe if there's a new framework out there, like suppose LangChain. So suppose someone was studying TensorFlow, PyTorch, or doing ML. So all of a sudden they're like, no, let's use this framework, or let's basically switch gears. So if you wanted to learn ML or AI in today's age, what would you do so that you have like a deep knowledge of whatever you're doing, but you also are like updated on the new technology that is out there and how you can maybe learn that in the future, because a lot is happening, and like people are trying a lot of things out, but then at the end of the day you're not really strong in your fundamentals a lot of times because you just know the methods. Like you just know how to
Yeah.
use LangChain, you just know how to use Lang index or something like this, but you don't know the fundamentals or what is actually happening in the background, and you're not really a master of anything at the end of the day. So if you were to learn ML or AI or learn something new in today's age where you have so many resources, you have so many frameworks, you have so many things going around in the world, how would you what would be your biggest advice, or how would you approach learning in today's age?
So I think there's, if you want to do learn machine learning today, I think there are two separate parts of it. One is basically learning the theory behind things, right? So knowing what algorithms are apply where, how, motivating them both statistically and analytically, right? And there are a lot of really good books. Deep Learning by Yoshua Bengio and the Goodfellow. That is one strong book, and there are many other books which you can actually get and get a fundamental grasp of deep learning, get a fundamental grasp of all these algorithms, get these architectures. There are a few landmark papers which you should go through, including Attention Is All You Need, and a lot of other papers like that. And those papers, if you understand that fully, that completes the theoretical aspect of it, and you should have great theoretical knowledge. And then every time there is a new conference, there's new RIP, CVPR, there is always best papers and top papers. You should always have an habit of going through them and seeing, okay, what are the latest and the greatest techniques. The second aspect of learning is the implementation side. And that my recommendation is never be loyal to any framework or never be loyal to anything. Just take what is new, what is shiny, and apply the concepts you learned in theory to actually build something, right? At the end of the day, a lot of machine learning is about engineering. And if you're able to engineer things, and if you're able to have sort of a problem you see around you, and if you're able to solve that with machine learning, that will be a lot more satisfying, and that will be a much better learning experience than anything else there is to offer. So learn the theory and then take whatever new framework there is, no matter what it is, and try to apply what you learned there and do it, right? Couple of months down the line, there's going to be a new framework, and then a
Yeah.
framework after that. And couple of months down the line, you'll think of another problem. And when you want to solve it, use that new framework, and then a new framework after that. Just keep doing that, right? So that is the that is my advice. The other advice I always have is that do not just stick to Python, right? So
Yeah.
I know a lot of young people I see today, only programming language they know is Python, right? And once again, look at, if you're doing machine learning, don't just basically think about making a model, training a model in Jupyter notebook, and that's it.
Yeah.
No,
Yeah. Yeah.
you have to think about ML ops. There's data pipelining. You have to do versioning. You have to do model serving, like the entire piece of it. Practice all of that. That is, I think, much more valuable than just knowing how to train a model, because
Yeah.
training a model is very easy. It's just
Correct.
calling a fit function, right?
Yeah. uh, Now that we've talked about training the model part, a lot of people still, I think nowadays, like 10 years back, maybe if you made a website or you made a simple like ML project, it would be pretty cool, right? But nowadays, like you mentioned, just training a model or doing something like that, I don't know, Boston house pricing or something like that, those sort of projects don't really help. So what sort of projects should we build? Like the open source contributions, fine. Like you mentioned, you did a lot of open source contributions. A lot of people go that route where they do a bit of open source contribution so that they can get some better knowledge. But if you're building personal projects, what should you be targeting? Should you like take a big problem that you have, or I don't know, you could even use Chat GPT to find a big problem
Yeah,
that's there. So like,
yeah. So
what's the entire flow of things? Yeah.
I would genuinely encourage people to think about a real life problem. So essentially a real life problem. Ask ChatGPT, ask people around you, and try to build a deep learning application around it. Right. So and then that problem you will have to collect the data. You will have to create the labels. You will have to train the labels. You will think about, okay, how do I keep my data and my labels up to date? How do I feed it into my system? I have to decide the model architecture, train the model, I have to serve the model, and then basically build some sort of a front end, like a mobile app or a website
Yeah.
to expose that, right? And that entire basically that cycle is the most important thing you're gonna do, right? And that is gonna be very relevant, right? And even 10 years ago, Boston house pricing data set was not that useful. It is a very good exercise problem which everybody should
Yeah.
learn, everybody should do, but beyond that, no,
Okay.
right? Uh,
Yeah. And what do you think about the relevance of DSA? Because recently Meta has announced that they will be allowing AI in their DSA rounds. They haven't like revealed the details too much. But what is your take on DSA? Because there's a huge sort of debate, and I think a lot of people waste a lot of energy in just thinking about whether they should do DSA, whether they should do dev.
So
So yeah,
my
what do you think
advice
on that?
on
Yeah.
DSA, my advice on
Yeah.
DSA is that it is definitely extremely important. Like I would never hire a machine learning engineer who's bad at DSA, right? I would, because I think algorithms are the key to everything. And it is at the end of the day not testing algorithmic knowledge, right? It is
Yeah.
just testing logic, because you don't know what kind of problems they're gonna come an year from now or 2 years from now, and the programmer you basically hiring, you don't know what kind of problems they will have to solve, right? But you'd want to work with smart people, you'd want to work with people who has a quantitative aptitude, and one of the best ways of testing quantitative aptitude is math, right?
Yeah.
However, when you are in the computer science world, you want to test the ability to program plus the quantitative aptitude, and competitive coding DSA is essentially the most fundamental thing to doing that. I myself have realized that if you have smart people, uh, like I've dealt with people who have an MBBS degree, who are doctors, who have no programming experience. But if you ask them to do maximum subsequence and those kinds of questions, they'll basically think for 15 minutes. They'll not know how to code in Python, but in C, they will write a DP solution. And they don't know what DP is, right? They've just thought of it, right? So, in a way, that is the kind of person I would want to work with, right? So, of course, I'd not hire somebody who has a medical degree. Maybe I will. But the idea is that it is not something that is to be basically be afraid of. It is something you can practice and you can be good at. The important thing is basically the logic development. And a person with a is with a good logic, or if a person who basically practices a lot, both of those kinds of people are appreciated. Both of those kinds of people will be hired. And I feel the importance of DSA is always going to be there in some shape or
Okay. Yeah, because it's pretty much like you mentioned, it's pretty much good for logic. It's sort of like mathematics, I would say in a way.
yeah.
Because in school, a lot of people, like even I used to have fun that there's a new problem. You try a lot of permutations, you try a lot of combinations, but at the end of the day, it's just about the logic. Even if you don't know
Yeah.
the formula and all of that is a secondary thing. But if you
Come
have
on.
built the logic, it is important. But when you are studying DSA, there's a lot of pattern. There's like two approaches now. I wouldn't want to call it the Jification. We could say it's a Jification because it's become more of like just a pattern recognition thing where people will
Yeah.
just go, they'll go like, yeah, we'll take these 100 problems, 150 problems, and then we're good to go. But I don't think that would approach in that would work in the long run, where you just know the fundamental problems, but you get what I mean, right? You didn't really study it to build logic. You moreover just memorize some given patterns, like sliding window or something like that, rather than actually having a conceptual grasp on DSA. So, what's your take? Like, if you're new to DSA, you want to solve DSA, how would you go about uh, solving DSA, both learning the programming aspect of things and also building logic so that, uh, you know, your quantitative aptitude basically improves over a given period of time.
So I think my take here is very simple, right? That the DSA we do for interviews and for getting into companies is a very basic, very basic level of algorithms and of what can be used, right? So there is one aspect is that you should do the study of algorithms. So you basically take up Thomas Corman and you study all the algorithms, and then you take advanced algorithm courses and you basically do the advanced side of things. And then you gradually get into TCS, theoretical computer science, complexity theory, and all that is like very fascinating. And the kind of questions people consider in complexity theory, like none of the DSA problems we see around here will be anywhere close to the problems. And there are problems I can state a lot of them. You can go to Wikipedia and find them out that we actually do not even know the most optimal algorithm to solve, right? So there are many such problems. In fact, some of the hardest problems in computer science is P versus NP problem, and all
Yeah.
that is essentially basically DSA, right?
Yeah.
But my take is that those niche difficult algorithms might come up at work, right? They might actually come up when you are basically tackling an engineering challenge, and you can always have a lot of literature to go review it, think about okay how people have approached it. You'll understand the way people approach it and then solve it in your own company or in your own industry situation, right? So the important thing here is to build that kind of capacity that if somebody gives you a very complicated problem, maybe you have some intuition of okay how do I approach this problem. And then if the question is too hard, if somebody else gives you a very complicated solution, you should have the ability to understand and comprehend that solution, right? So when you say so I think knowing that and having that perspective is very important. If you just want to prepare for interviews, there is no harm in Jification or no harm in pattern
Yeah.
matching.
Correct.
But if you, because that is a very small goal, right? And that is something you can
Correct.
be very good at, right? However, the key important thing for young people and people who really want to make an impact is that you will have to be in a you should have to, as I always say, you have to develop an intuition of this is a problem. Okay, what it's not pattern matching, it's more like okay, how will I approach this
Yeah.
problem, right? And if
Correct.
something very complicated or some very complicated variant, you change one thing and it becomes an intractable problem.
Yeah.
Like fractional knapsack problem can be solved by greedy. And if you just remove the condition of fractional, it can, 0 1 knapsack problem can't be solved by greedy. Like you have to use dynamic programming. And there are other variants of that problem where there is no other way other than brute force, right? Where you
Yeah.
can actually solve them. So
Yeah.
if somebody gives you a tiny complicated variant of a problem, you should know that this problem is something I can tackle and this problem is something I cannot tackle, right? So
Yeah.
determining hardness of a problem in at work, I think, is very important.
Yeah. And the PNNP problem, I think I was also recently studying. I think I was studying for some exam or something like that. Like I had studied a bit of it before, and then I went on YouTube by random research, and then this podcast came up. I think it was with Lex Friedman, if I'm not wrong.
Yeah.
And the way he sort of explained, I think it was a 20-minute long video. I had my exam the next day, but then it was so intriguing once we actually got to dive deep into what P versus NP problem is. I sort of got I don't know, I got distracted in a way, and I ended up watching a few more videos just to understand the P versus NP thing. So yeah, that was something I wanted to mention from my
There's
end. Yeah.
there's something called complexity zoo.
Yeah.
You can just go to Google and type complexity zoo, and you'll figure out it is basically run by this very famous professor called Scott Aronson. And that complexity zoo is full of all sorts of these problems. And P and NP are just one class. There are thousands of such classes of problems. There is, all sorts of NP0, EXP, three some hard, so many classes of problems. And figuring out and understanding these classes of problems is what people study.
Yeah.
Uh,
Yeah. And that gives a great perspective, I would say, just so that the audience understands how shallow, like that, like you mentioned, that the DSA we study for interviews, they are limited. Even at top companies, they would be, I think, limited to
yeah,
some a certain extent, or they would repeat after a given time. And if you're talking about normal companies or service-based companies, it is pretty much the basic DSA where it's just dealing with strings, arrays, things like that. And I think that is quite important to understand from a programming perspective as well, because it's like you just have one drop of the entire sea. The sea is really big, so there's a lot to explore even after you have understood the fundamentals of
yeah.
DS.
Yeah, so for like one of the things in these coding interviews, and it is this how restrictive that they'll never ask you anything about randomized algorithms, right? That is extremely fundamental. So it's you go slightly above the DSA bubble, you come to randomized algorithms, and randomized algorithms is a large set of like so many things in industry is a randomized algorithm, right? So and I would urge everybody to go check out. Like, let's say if I ask you a question, let's say you have an array of size n with a guarantee that n by 2 of the elements are A's and the other n by 2 are B's, right? And they're randomly shuffled. Can you essentially give me an index where there is a letter B? So the best deterministic algorithm, you basically have to brute force search,
Yeah,
and that is going to be O of n by 2 or O of n, right?
yeah.
However, if you just sample, the you we can pretty equal the expectation is O of 2, but it
Okay.
doesn't work quite like that.
Yeah,
Uh, but so the question is that with the randomized algorithm, you'll be able to do that much quicker than let's say a traditional brute force, right? So this is a very simple sort of an example, but there is so much more like depth in this as we move forward.
yeah. So I was recently reading this article. I think it was on Times of India or something. I don't remember the source, where they were mentioning that specifically in India, for every 10 human requirements for a AI engineer sort of role, they're just able to get one sort of resource that has enough knowledge to basically become an AI engineer. So, like, you are an ML engineer, but nowadays, since you are working with LLMs, RAGs, and things like that, I think as an ML engineer, most people have pretty much uh, transferred a bit into an AI engineer, you can say, where they are dealing with these everyday things like LLMs, RAGs, and things like that. So, based off of this article, what do you think are the skills that are needed to become an AI engineer? Because a lot of people want to become this ML engineer slash AI engineer.
Yeah.
And in AI, there's a lot of things to cover because a lot of people, they just feel that using Gemini's API or using Olama or using OpenAI's API is pretty much can be classified into an AI project or can be classified in
Right.
that domain.
So
But yeah, what are your
So I
take?
think we will come to that. We can come to that. But I mean, I was a bit confused when you say an ML engineer and AI engineer because they're pretty much the same thing.
Yeah, yeah,
I mean,
yeah,
in
correct,
Google, you even don't have those titles. Google, everybody is
correct.
a sort of
Yeah,
right. So I like that, right? So I mean, no matter what tag you give,
correct.
essentially, I think for a lot of what you would call as an ML engineer, I think this important skill set, once again, as I said, are just understanding of how the algorithms work, understanding of some popular frameworks, looking into okay how data is loaded, how these models are served, so understanding architecture. So the entire backend flow. Okay, if there is an API call to a model to get some inference, how do you basically serve that API? How do you scale up the entire service? I think those are the kind of skill sets that will be essentially required. General understanding of backend engineering and a proper understanding of the machine learning, the ML ops side, where you're basically looking into
Yeah,
the data, loading the data, and training the model. Uh, as far as just broadly what the role consists of, I think the role is, especially actually even before that, what you said is that just people, just call the Gemini API or people call the
yeah,
OpenAI API and say that is a deep learning project. That I would say is a very downstream project where
yeah.
you're using
Something
these
correct.
APIs to do something. However, in real life, these API, in actual engineering situations, most likely you're not going to do that because these APIs are extremely expensive
Correct.
and they don't scale. There is also inference constraints. So you basically
Yeah.
are limited by the amount of queries you can send per
Make. Yeah.
second.
Yeah.
So a project you will build where you pretty much have the entire model on your own side, where you actually scale that model up, you train that model, and then you deploy that model. I think that is a more ideal sort of a project.
Okay. So yeah, because yeah, that is the issue with OpenAI or things like that. Also, like Shiva mentioned, that you should probably do everything on your end, like scale it, train it, fine tune it, do things like that. So when we talk
Of
about
course,
LLM, yeah,
you should know how to use the OpenAI and Gemini API.
correct.
That is also important, but that should be a part of it, not everything.
Yeah, yeah. So, Shivam, when we talk broadly about AI, there's LLMs, there's a lot of things going on, right? There's RAG, there's graph RAG. There's now agentic AI nowadays, where the agent is able to do a lot of things by its own. So, when you are new to AI, uh, do you have any suggestion? Like, do you have some project suggestion, or like just talking fundamentally about AI, leaving behind the ML aspects of things, because we've covered that in quite detail, right? Talking fundamentally about AI, like using LLMs, learning how to do RAG and things like that. How should one go about doing that? Because you have a pretty decent experience with that as well, right? You're currently working on LLMs, RAGs, things like that.
So I
So
mean,
yeah, what's your take on this? Uh,
as so when you look at just in detail about LLMs, you should understand okay how LLMs work broadly, like so understanding the transformer architecture, understanding like different open source models and how that is done, right? How would you
yeah,
train an LLM? You most likely will never have to train an LLM, but you
correct.
should know how the training works. Second thing is you should understand fine tuning, right? So there
Yeah,
are a lot of platforms where you do supervised fine tuning of these LLMs. I think you should have a good grasp on SFT, supervised fine tuning, and LoRa, QLoRa, and a lot of other
yeah,
algorithms which people have come up with to do that. The other aspect is the RLHF. So the other kind of fine tuning is basically generation of synthetic data and fine tuning on with reinforcement learning. So LLM fine tuning with reinforcement learning is extensively used, right? And understanding PPO, GRPO, and those algorithms, I think those are
yeah,
very important. And actually trying to take some small open source model and train those models, right? Also, you should think about okay, how do I scale up inference? So understanding LLM inference. So basically, a lot of techniques, like speculative decoding and those kinds of ideas, techniques. How do you implement it? VLM, something like that. That is also critical, I think, for today's day and age.
okay. And what about things like RAG and those other sort of things like agentic AI
That
or
is that is the bare
randomized?
minimum.
That
I
is
would
very minimum,
assume
correct. Yeah,
that is
yeah,
the bare. You should know how to. I mean, it takes a
yeah,
few hours to understand how to do RAG, right? In
correct.
RAG as well, the actual question is, can you do query understanding? Can you do
Yeah,
query classification? It's not just about basically just sending things to a vector
yeah, sending the
database
input.
and
Yeah,
driving things to a vector.
yeah,
So the
correct.
entire pipeline of how can you really optimize RAG, and then for RAG there is going to be there's going to be ranking, there's going to be retrieval, there's going to be retrieval, ranking, re-ranking, and then you're going to use it in the RAG.
Yeah,
Like the entire pipeline, one should understand.
okay. Yeah. So what is your what are I would want to know some future predictions from your end, from your personal end about AI and where the world is going, because there's so much, there's a lot that is happening. Like every day, there's something new. There's
So
deep
of course,
sea coming. Yeah, yeah,
such things in podcasts become meme materials, right? Because
yeah.
you'd say something, and in
And then
couple of
yeah, it becomes viral all of a sudden.
happens,
Yeah,
and it is like that. So I would risk myself becoming this might be relevant, this might or might not happen. But as I've always said, this is a pattern we've always observed, that there is some sort of a breakthrough that happens, and
correct.
then there is a lot of compute thrown at it, and
Compute.
then
Yeah,
whatever gain you milk from it will basically is milked, and then there are new breakthroughs that
yeah,
happen,
yeah,
so on and so forth. I
yeah,
think the breakthrough with LLMs, I think, has already done. So the text-based LLMs, I think, where you could basically train
yeah.
text, right? That is already done, and people have put as much compute as you can put, right? And we've seen that ChatGPT 4 was much better than ChatGPT 3.5.
Correct.
4.5 was not as much better than 4, and
Yeah,
5 now is not as much better than 4.5,
four. Correct.
right? So it's
Correct.
essentially
Yeah,
there's diminishing returns, and the
yeah,
amount of money and the compute it was trained, these things were trained on, was drastically high, right? So now we'll require some other strong breakthroughs. And you can think about where those breakthroughs can actually come in, right? One of the things where that breakthrough can come in is basically world knowledge and world models, right? So if you want to think about, okay, a small 5-year-old, there are a lot of things an LLM cannot do, a 5-year-old can do,
yeah,
right? And one can ask, why is that the case? LLM basically knows everything it's trained on all sorts of text the world has ever produced. Then why are there things that a 5-year-old can do and the best LLMs today cannot do, right? And the reason why is that if you think about it, 5 years of age, that is basically 365 times 5, and you can subtract the sleeping hours, so that's one third of that time. All the other hours, people are awake, and then your eyes are open, so this is input. Your ears are basically open, so all audio input, and you're basically just training your model through that, right? And so there are a lot of things you would learn from this world model sort of a thing, right? Where you would kind
yeah,
of understand, like, say things fall, you don't need to understand the law of gravity. If I say what happens when I put a cup here, it falls. That is something you learn by intuition. So if I want to train that model with just text, that is going to take so many words and gravity and so much
Yeah.
logic of what's going to happen. But if you have a visual understanding, it just happens to you. So you infer physics. You might not know what the law of sines or cosines are, but you'd realize that, what takes more effort, what takes more force. So I think these world models will be coming up, and we'll have to think about how to train these models and how to deploy these models. That is what is coming up. Of course, agentic AI is going to become better. It's basically these models will become better decision making, but all that is not going to happen through fundamental LLM advances. That is just
Correct.
going to happen around the scaffolding we build with these LLMs, right? So even if there is no sort of LLM, no new LLM that comes out, I think we have decades, like years and years of work which you can do in revolutionizing the existing industries with already what we have.
Yeah.
Right.
What would be the two most important things that you feel a someone entering first grade or someone very young should do? Because we don't know what's gonna come up by the time that they
Yeah.
get to our age, or
So,
how the world's gonna
so
work. So what are the fundamental, like two fundamental skills that everyone should have?
so I think one of them is the is math, right? The ability to do mathematical reasoning and mathematical thinking. We don't know what the next great model is, or we don't know
Yeah.
what things are, but you will have to be good at math to understand whatever it is, right? So I
Yeah.
think one of the things is basically having a quantitative mindset and the ability to do mathematics is I think super important skill set anybody should learn when they're young, and even when they're old, whenever you sit
Yeah.
down to learn. And the second thing is just this attitude and this ability to learn and unlearn and then relearn, right? That is something we basically are always taught, that this is what you learn, these are the facts, and you build on top of it.
Yeah.
There is unlearning that needs to happen. There are new things that are going to come up. Just the ability to cope up with uncertainty, that there are going to be, even if you're an expert, there are going to be new things which are going to stump you. And you'll just have to keep on adapting, keep on learning, unlearning. Just that attitude, I think, is something young people should learn to develop. Right.
Okay. So
So I
pretty much
think these
math
two
and
things,
attitude.
math
Yeah.
and the attitude to learn and unlearn, I think is that is what's going to remain constant. I think other than that, anything I say might be subject to change.
Correct. Uh, Shivam, you've lived in the US for quite some time now. What would be your biggest learning from both from the US's culture and India's culture? Like, what is some value system that you learned over there, and something that people should learn from both countries? Because I think it's quite important to shed light on that as well. Because you go to a new environment, there's a new sort of entirely new sort of mindset that people generally have. Correct. So, what is the biggest learning that you have taken from the US culture, and the biggest learning that you can think about from the general Indian sort of culture that you grew up in?
But I think one of the things I've observed in the US is the voracious appetite people have in taking risks and making big bets, right? I think San Francisco, Silicon Valley is one of those places where if you basically leave your job, people congratulate you. I think that is pretty much the only place in the world where that would happen, because
Yeah.
it's like you're starting something new. So the ability to take risk, the ability to make long-term bets and allocate outsized amount of capital to those long-term bets, I think is something that is a part of US Bay Area like culture, which
Yeah.
technology culture, which I think has paid off a lot, not only to the US but to the entire world at large. And I think that is something I take from the US, the ability to take large risks. On the India side of things, I think the amount of importance we have on education, the amount of importance we have for discipline in our lives, right? I think that is something very important. I think it's very, very important to be disciplined. It's very, very important to learn things, keep on learning things, and have like a systematic path where you know that this is the way to go ahead. And I think that is something you learn from India, right?
Okay. Yeah. And how's life in the Bay Area? A lot of people are very curious about that because it's probably a totally different experience, right? Once you directly move into it. So how's life been in the Bay Area? And yeah,
So I think Bay Area has everything for everyone. And you can go play basketball in the Bay Area and people are talking about startups. You can talk to an Uber driver and talk about startups. So there are fantastic universities like Stanford and Berkeley where the best of the best happens. There are great companies where like millions of customers are served, and there are also small companies, and there's a lot of hope for that. So I think in general technology, the scene is very open. People are doing fantastic things. You'll see a lot of startup billboards. You'll see this new gadgets and new robots out there. So you weigh more cars and all sorts of things. So it makes you realize that it is a very interesting time to be alive, and it's very interesting time to be here. But whatever happens in the Bay Area has a outsized impact outside of the Bay Area, right? And
Yeah.
I think one should at least come here once to experience this. Is
Yeah.
something I'll say.
Yeah.
I live in LA. I commute to the Bay Area every week, so that is, I think, and that is how important Bay Area is,
Yeah.
right? So.
Yeah. So as we sort of go towards the end of the podcast, I wanted to talk a bit about your mentality because I observed a lot of positivity in your mentality, and I think you could relate your journey to a lot of prodigies, so as to say, like Sachin Tendulkar, someone of that age, where at 16 years of age he was playing cricket, or some other folks like that. Something I have noticed with watched a lot of podcasts personally, with these top level athletes or folks like that, like Kobe Bryant, LeBron James, Tiger Woods. I don't know, someone from cricket, Virat Kohli. So they started off really early, and they led, you can say, really disciplined sort of lifestyle. And at the end of the day, I think it fell on their mentality entirely, because the skill aspect of things, that I think is probably 30 to 40% of where you go, because there's probably a lot of people that have the same skill as you, but they don't have the same mentality, so they don't really rise up to everyone's expectation or even their own expectations. So I wanted to ask you sort of this mental question from your end. I don't know, Ki, how are you like exactly? I don't know if this is the right question, but how exactly are things wired in your brain? Or what is some mentality thing that I think you feel that you always had in yourself? Maybe it could be willpower or something like that, that you feel has been instrumental in leading you to wherever you have reached thus far, and it is gonna help you grow in your future endeavors, just from the psychological
So,
mental sort of aspect.
so I mean, one of the things is about, prodigies and those kind of
Yeah.
things is I strongly believe that beyond mental, of course, there's some sort of thought process and mentality, but I think luck is a huge factor, right? And we have to
Yeah.
acknowledge that. I always acknowledge that. One of the things I realized is that, I was very fortunate to have a lot of things. I'm fortunate to have parents who had the right attitude. I was fortunate to be born at the time of the internet. There was a lot of things that fell into place, and it's basically the accumulation of advantage, right? That,
Yeah.
when you're young, you get to do things and you get more opportunities, and then because of that, it is this huge accumulation of advantage that happens in life, right? So I first would want to acknowledge that a
Yeah.
lot of what I have achieved is not because of some attitude or some miracle I did, but that I was plain very lucky, and I was really interested in things I did, right? So that is, and the fact that I was interested in things was also a factor of a
Yeah.
lot of luck
Yeah.
on my part. The second thing is the attitude wise. I think one of the things that I have seen people who have mentored me, and I've seen people, is like a lot of perseverance, right? That you basically have to have that grit. That, irrespective of what happens, you'd want to do what you want to do, right? And not chasing tags, essentially, that, you want to go to
Yeah.
this company,
Yeah.
that company, but essentially chasing, if you're really passionate about something, just basically being on that path and just moving towards it inch by inch, closer by closer, irrespective of what happens in industry. I think that is super important, along with the fact that there's going to be tremendous change. So you'll have to change your course. You might not reach where you exactly intended to reach, because that is no longer a destination that is available to reach, but a general sense of, okay, what domain do I want to go, where do I want to make an impact, and then just gradually just moving towards that, I think is super important, irrespective of what happens. Not just giving up, and just doing things and pushing things, I think is super important.
Yeah.
And just embracing change, embracing uncertainty, and making probable right bets. Like, one of the things you'd realize is that you'd want to make good bets that are for AI, right? You'd want to make bets that are like for more sustainability. So you cannot know which exact companies or which exact kind of endeavors are going to work, but the large bets, like where do you want to make you want to make a bet on like pro AI, pro sustainability, pro, like there are like definitely some areas you can think about that these things are surely going to work, and then you pursue those areas. I think that is very worth. about
Yeah.
thinking about thinking.
Yeah, and that reminds me sort of like about the Bhagavad Gita, where the luck part of things, where there are a lot of things that aren't really in your control, and I think that would also follow that philosophy, correct? Where
Yes.
there's nothing in your control. Like you can do the work, but there's nothing that is pretty much in your control. And I think if you have that
Yeah.
sort of mentality, you would be able to accept it rather than I was reading somewhere that there's three kind of people: one who blame others for their mistakes or shortcomings. There's a second kind of folks that are a bit better, where they take responsibility, and then there's a third kind of people who just sort of embrace it, that yeah, I couldn't do what I wanted to, and then they move forward from there. They sort of understand that not everything is in your control, and like you mentioned, luck factor also has a lot to play in one's journey. So yeah, thank you so much, Shivam, for coming to this podcast. It was really nice getting to know you. I personally learned a lot because based off of the experience that you have gathered, you're still young. I mean, you're still not that old, but based off of what you've done so far, you've learned a lot of experience. And I think we did a good job in basically putting out that experience to the world, where people can think from a broader perspective. And that is what I wanted at the end of the podcast. I wanted a broader picture of things rather than just being just talking about something that doesn't have a lot of importance. So we, I think, explored everything. Like we looked at that, we got an idea about the entire sea, because a lot of people are like that frog in their own pond, where they don't know
Oh,
anything beyond that small pond. But it's really important to at times understand the entire broad perspective. And yeah, thank you so much for coming. Is there some final message you want to tell the audience or something like that? You can mention that if there's anything left.
I think I'll just tell the audience to just remain curious and be open to whatever new that comes, and just I'm also in awe of what we'll be able to do with AI, and it is basically a community thing that we'll all have this technology in our hands, and I'm just do something awesome in whatever domain you're good at. So I think that is the only thing I'll say.
Yeah.
Right.
So once again, thank you so much, Shivam, for sparing some time. It's quite late at night. For the people that are wondering, we're doing this podcast quite late. And you had to make some time out for this podcast. So yeah, thank you once again.